Hi, everybody. It's Professor Mitchell. We are continuing with Chapter 9. Today, we're talking about conducting a hypothesis test for population mean, where the population standard deviation is unknown. So we started talking about that in the last video, and today we're going to talk a little bit more about the p-value approach to doing that type of hypothesis test. So the assignment that corresponds with this video is conducting a hypothesis test for mean, population standard deviation unknown, p-value approach. The objectives of this section are to determine the p-value for a hypothesis test for the mean, where the population standard deviation is unknown, and then make a conclusion and interpret the results of a one-mean hypothesis test where the population standard deviation is unknown using the p-value approach. So this hypothesis test uses the t-distribution with n-1 degrees of freedom. To perform this test, the test statistic t is computed using the formula below, where x bar is the sample mean from a random sample. Mu is the hypothesized mean. Remember, that's the mean that appears in the null and alternative hypothesis. S is the sample standard deviation, and n is the sample size. So this looks very similar to the formula that we used when the population standard deviation was known. The difference is that we're using S in place of sigma, and this test statistic follows the t-distribution instead of the z-distribution. To identify the p-value for a left-tailed test, use any method to find the area to the left of the t-test statistic. So it turns out to find p-values for this kind of test, you really have to use technology, all right? So I'll show you how that works. To identify the p-value for a right-tailed test, find the area to the right of the t-test statistic. And finally, to identify the p-value for two-tailed test, find twice the area to the left of the t-test statistic when t is negative, or twice the area to the right of the t-test statistic when t is positive. All right, and again, we will be using technology. There's really no other way to do it. The only thing you can sort of come close to doing if you're just working with table A3 is to find an interval for the p-value, all right, which is usually good enough, but we may as well use technology. All right, so here's an example. An advertisement for a wireless speaker claims that its range is 10 meters. Fabian tests this claim by randomly selecting 34 units of the wireless speaker in question. He measures the range of each speaker from his smartphone and finds that the sample mean is 8.86 meters with a sample standard deviation of 0.42 meters. And they want us to find the test statistic t rounded to 2 decimal places. So that's pretty simple. We're just going to use the formula that we were looking at a little while ago. Since the population standard deviation sigma is unknown and the sample size is at least 30, the hypothesis test for the mean can be performed using the t-distribution. Here, the hypothesized mean is mu equals 10. That's the mean from the claim. The sample mean x bar is 8.86. The sample standard deviation is S equals 0.42, and the sample size is n equals 34. So substituting these values into the formula to calculate the test statistic, and this is something you should absolutely try in your calculator. We get the t equals 9.86 minus 10, and then divide that difference by 0.42 over the square root of 34. Should come up with negative 1.94 for the calculated test statistic. All right, here's another example. This time we're finding the p-value. Your friend Tabitha claims that her commute from her house to work is less than 30 minutes. To test this claim, she randomly selects 25 days over the course of a year and measures the commute time to work. From the 250 data values in the sample, Tabitha calculates that the mean commute time is 28 minutes. I just noticed that 250 doesn't make a whole lot of sense. I'm sure that's supposed to be a 25. Sorry, I really do scan these things for typos, but I don't always notice all of them. All right, so I'm pretty sure that's 25 data values. Tabitha calculates that the mean commute time is 28 minutes with a standard deviation of 5.5 minutes. If the test statistic is t equals negative 1.8182, so they've done that part for us this time, and the alternative hypothesis is mu is less than 30, and that would be the appropriate alternative hypothesis because that's what her claim is, right? Her claim is that her commute is less than 30 minutes. So we're going to find the p-value for this hypothesis test rounded to 3 decimal places. Okay, notice that the number of degrees of freedom for this test is 25 minus 1 equals 24, and it's left-tailed because the alternative hypothesis is mu is less than 30. So remember, whenever the alternative has a less than sign, that makes it a left-tailed test. All right, so finding the p-value for a left-tailed test with 24 degrees of freedom. Let's fix that. There's another one I didn't see. This might change the value, might change the p-value just a little bit. I was planning to show you how they got this anyway. Well, actually, not how they got it, but how we're going to get it. All right. Here's a nice picture of what that p-value represents. It represents the area under the curve, the t curve, to the left of negative 1.8182. All right. So according to them, the p-value that corresponds to these conditions is approximately 0.0408. And it looks like they used a graphing calculator. All right. I am going to show you something different because not everybody has access to a graphing calculator. Let me just try to get out of this. Okay. Okay. All right. So I'm pulling up my browser where I have already gone into Google and typed in t-distribution calculator. The first thing that comes up is my favorite website, StatTrack. So I'm going to open that up. I'm pretty sure I've shown this to you before. Okay, it's a little slow, but it's coming up. There we go. Okay. All right, so my random variable is t-score. Degrees of freedom is 24. So eventually it should let me type in this box. There we go. Okay, and then the t-score is negative 1.8182. So when I hit calculate, notice that what's going to come up in this last box is the probability that t is less than or equal to whatever value is typed into this box. So since we're doing a left-tailed test, that is exactly what we want. Okay. So I'm going to hit calculate. I have oh, there we go. Okay, 0.0408. So when they did it on the graphing calculator, they must have put in 24 degrees of freedom, even though they did have that typo 25. All right, so going back to the PowerPoint. Computer is a little slow today. I think I have too many things open. That might be my problem. Story of my life. All right, so remember the decision criterion for a one mean hypothesis test using the p-value approach. If the p-value is less than or equal to the given significance level, then the null hypothesis should be rejected. When p is low, the null must go. When p is high, the null will fly. If p is less than or equal to alpha, reject the null hypothesis, otherwise fail to reject the null hypothesis. When we have made a decision about the null hypothesis, it is important to write a thoughtful conclusion about the hypotheses in terms of the given problem scenario. I believe you've seen this a couple times before. Assuming the claim is the null hypothesis, the conclusion is then one of the following. If the decision is to reject the null hypothesis, then the conclusion is that there is enough evidence to reject the claim. However, if the decision is to fail to reject the null hypothesis, then the conclusion is that there is not enough evidence to reject the claim. On the other hand, if the claim is the alternative hypothesis, the conclusion is either, in the case of rejecting the null hypothesis, the conclusion would be that there is enough evidence to support the claim. If the decision is to fail to reject the null hypothesis, then the conclusion is that there is not enough evidence to support the claim. So always state your conclusion in terms of the original claim. So here's the Tabitha example back again. So this time we're going to make our conclusion. Tabitha claims that her commute from her house to work is less than 30 minutes. To test this claim, she randomly selects 25 days over the course of a year and measures the commute time to work. From the 25 data values, they fixed that typo this time, in the sample, Tabitha calculates that the mean commute time is 28 minutes with a standard deviation of 5.5 minutes. The test statistic T for a hypothesis test of null hypothesis is mu is greater than or equal to 30 versus the alternative hypothesis mu is less than 30. Just like in the last example, that test statistic is negative 1.8182. If the p-value is 0.0408 and alpha is 0.05, what conclusion can we make about Tabitha's commute time? So notice that p is less than or equal to alpha. That means p is low. When p is low, the null must go. So we reject the null hypothesis, and Tabitha's claim was that her commute was less than 30 minutes. That became the alternative hypothesis, so there is enough evidence to support her claim. Our claim was the alternative hypothesis, and we rejected the null hypothesis, so there is sufficient evidence to support her claim that her commute from her house to work is less than 30 minutes. Here's another example. Dalton reads an article in a local newspaper that claims the mean amount financed for a new car loan in the region is now greater than $32,000. He tests this claim by randomly selecting 82 individuals in the region who recently financed a new car and asked each individual for the amount financed. Dalton determines that the sample mean amount financed is $32,704 with a sample standard deviation of $6,781. the test statistic T for a hypothesis test of mu is less than or equal to 32,000 versus Dalton's claim that mu is greater than 32,000, that test statistic came out to 0.94. Now let's pause here for a second and see once again how they came up with this p-value. I am going to go back to, actually I need to open my browser again. I closed down a bunch of things because my computer was running very slow. Okay, so I'm back in StatTrack. Let's see, this time I believe the degrees of freedom is 81 because his sample size was 82. The t-score they gave us was 0.94. Now this time I want to be careful. This is a right-tail test. This number that comes up in this box is going to give me the area to the left of 0.94. So to get my p-value, I'm going to subtract this value from 1. So we hit calculate, we come up with 0.825. 1 minus 0.825 is 0.175. So that's very, very close to the p-value that they gave us, which was 0.174. All right, so since that p-value is 0.174 or 175, it doesn't matter, and the level of significance is 0.1, what conclusion could be made about the mean amount financed for a new car loan in the region? Well, this time P is high, and when P is high, the null will fly, right? So Dalton's claim is the alternative hypothesis. This time, we do not have enough evidence to support that claim. We are going to fail to reject the null hypothesis. So that means there is not sufficient evidence to support Dalton's claim that the mean amount financed for a new car loan in the region is greater than $32,000.